Question 31. According to a thermodynamic model of the cooking process, the time T required to cook a joint of meat mass M is given by the following formula. Rho, C and mu are respectively the density, specific heat capacity and thermal conductivity of the meat, and alpha is a dimensionless constant with a value of 0.029. Using dimensional analysis, the value of K is which of the following? Let us study the dimension of each parameter one by one. First, time is simply one of the fundamental dimension, denoted by big T. Alpha is dimensionless, so we can simply assign 1 to it. Next, density is mass over volume, and volume has the dimension of length cube. Hence, rho to the power k has the dimension of m to the power k over L to the power 3k. Coming the mass, it is simply denoted by big M since it is also one of the basic dimension. For specific heat capacity, we know that it is defined as heat energy per unit mass per unit temperature change. Then, we can also further transform energy into force times length. Knowing from Newton's second law that force is mass times acceleration, we can express the dimension of the specific heat capacity, C, as L cube over T square theta, where theta represents the dimension of temperature. Lastly, for thermal conductivity, we can identify its dimension from the equation of thermal conduction. This allows us to see that thermal conductivity has the dimension of energy over time multiply 1 over area multiply length over temperature. With this, we can show that the reciprocal of thermal conductivity is T cube theta over ml. Now, all our ingredients are ready. The last step is to equate the dimension of time to that of all the parameters on the right. In order to have equal dimension, the unknown k must work in a way of making both m and l have zero power, and at this point of time, it is not hard to see that k must be 1 over 3. Thus, the answer is D.